let's talk about the e to the x situations. You know the antiderivative of e to the thing is e to the thing, except when there's some complication. So over here, I'm going to say let u be equal to 4x, because it's a little complicated. It's worse than just having a plain old x. And then, as always, du is going to be the derivative for, right, 4 dx. So this is kind of a differential. But I don't need a 4 dx. I just need dx. So I'm going to divide both sides of this by 4. So I can have my dx there. And then I can rewrite this as 1/4 e to the u du. Again, dx gets replaced with 1/4 du, but I can take that constant outside. So the antiderivative of e to the u is just e to the u. So we're going to have 1/4 e to the u, which I really know is e to the 4x plus c. And for number 12, this is fortuitous because what u would have to be equal to, I can see that I have the derivative of this x to the 5th thing right there. So again, u is going to be the exponent, and then du is 5x to the 4th dx, right? You got to keep in mind the rules for taking derivatives and antiderivatives. We don't need a 5x to the 4th, we only need an x to the 4th, so we'll get rid of that 5, divide both sides by 1/5, or multiply by 1/5, whoops. And we're going to bring that 1/5 outside. We'll have e to the u du. So our antiderivative is 1/5 e to the u is x to the 5th plus c. And everything's good. Let's do a few more e to the x's. 13 e to the 4th. E to the 4th is just a number. And the antiderivative of a number is just e to the 4th times x plus c. And for number 14, ln x is always a problem. So I have no option but to let u be equal to natural log of x. And then nicely, du is 1 over x dx, which in fact, I can rewrite this fraction as e to the ln x times 1 over x dx. Because when you multiply fractions, you multiply the tops, multiply the bottoms, so everything is good here. So this is just the antiderivative of e to the u du, which is just going to be e to the u, so we just have e to the ln x plus c. Might as well finish this off. You get the idea here. U is going to be x to the 4th. Du is 4x to the 3rd dx. We don't need that 4 there, so we have 1/4 du is x to the 3rd dx. So we can rewrite this as 1/4 e to the u du. So we're going to have 1/4 e to the x to the 4th plus c. And same gag here, right? We have sine x is going to be our u, and du is cosine x dx, so it just works like a nice little jigsaw puzzle coming together. We have the antiderivative of e to the u du, so we know we're going to end up with e to the sine x plus c.